what we were doing, we were doing a set of questions based on the topic kinematic equations of for uniformly accelerated motion. And now, what we are going to do in this session is we are going to cover certain set of questions which are basically based on solving the scenario where the body is projected upwards from the ground or maybe from a height. And when I say projected upwards, I mean projected vertically upwards, right? Because when we say projected alone, not saying projected vertically, it simply means that the body is undergoing a projectile motion, right? So those questions, all the questions which we'll be discussing in this session will be the vertical motion of a body from the ground or maybe from a height. Having said so, let's move on to the first question. A cricket ball is thrown up with a speed of 19.6 meter per second. The maximum height it can reach is okay. So first things first, diagram, ground, ball is thrown up to reach a maximum height, and then the ball will trace down its path. It will come down, right? So this is what happens when a ball is thrown up. The maximum height it can reach is okay. So the diagram is done. Now the labeling. So this is position A. This is position B. Corresponding velocities are VA. Corresponding velocities are VB. Okay. Now the body starts from A, right? So A is the start point, and it eventually ends at B. So B is the finishing point. Okay, or the final position. That would be more correct to say. The final position. Okay. Now we can use the equation v square minus u square is equal to 2 into A into S. See, the most important query that comes often to the mailbox or maybe to the among the offline classes is that students ask me this question: how to make sure that we take the direction of acceleration due to gravity correctly, either as positive or as negative. And people, I have seen students trying to by heart and trying to mug up the scenario and the sign notation. See, this doesn't make sense. Physics is a very logical subject, so you should be trying to understand the basic logic behind it, right? So I'll try to do is I'll try to explain that sign convention when and where possible, and where all is it's necessary. So it goes like this: the body is projected in the upward direction, whereas the acceleration due to gravity always acts in the downward direction. So now, if you understand the concept here, if you take with respect to the reference axis, if you take the upper portion to be positive and the lower portion to be negative, we can say that velocity which is moving upwards is positive, and acceleration due to gravity which is acting downwards is basically negative. So what we'll do is we'll take velocity as positive and acceleration due to gravity as negative. So now you may ask me, so then how will you find out the direction of displacement? Wait, I'll come to that. Okay, I'll come to that. You just hold on for some more seconds, and or maybe some more problems, and all your queries relating to the direction of displacement, velocity, acceleration due to gravity, all of them will be cleared. Now, as far as this question is concerned, all we need is this sign convention. So what we'll do is we'll now substitute the values. So what is V? V is VB, right? So V is VB square. What is U? U is VA square, or let us say UA square. Okay, UA square is equal to 2 into A. What is A? A is G. No, A is minus G. So A is minus G into S. S, we can write this as what's been asked in the question, which is the maximum height, right? So this much in this sense is the H max, right? Now, let me make a statement which should be in your mind no matter what solving any question of any type in this topic. It goes like this: when an object is thrown up from the ground, it will go a linear path. It will come to a maximum point and then it will retrace the path and then come down and reach the initial position. We need to understand this in a more diagrammatic manner. So if a body is projected from A, it will go like this, right? It will take many points. The velocity here would be the maximum velocity by which it is thrown, because the acceleration due to gravity is negative and it will always reduce the velocity. And as the velocity becomes reduced, so say for example, the velocity is reduced like this, it reduces like this. At one point of time, the velocity will become zero. And at this point, the body is momentarily at rest. The body is momentarily at rest. And then the body will come down again and reach the ground at B. So, though I have drawn this diagram, in an ideal situation, it will happen like this, but sorry, in a practical situation, it will happen like this. Whereas in an ideal situation, it should go up and then come back the same straight line, right? Go up and come back the same straight line. But this is what happens in a true picture. Or rather, in a reality condition, the body will trace like this. What are we talking about? Motion in a straight line. Vertical motion. Body thrown upwards. Body is thrown upwards from A, it will reach the maximum point B, and then it will come down. Now, don't try to understand the concept in terms of defining the path. If the body is thrown with VA, which I mean is plus VA, the body will come here, reach this point, and at this point, the velocity will become zero and then it will turn negative. Why? Because if the upward direction is positive, the downward direction is to be taken as negative, right? If you're not clear with the concept, don't pause and replay the video. Don't do that. Complete the set of questions. Your doubt will become okay. So now here, VB is the final position, and as I said, the body will be momentarily at rest at the maximum height. This value is going to be 0. So UA is basically 19.6 meter per second square. So we have 19.6 meter per second square is equal to 2 into G is minus 9.8 meter per second square into H max. So what is H max? H max would now be equal to 19.6 times 19.6 the whole upon 2 into 9.8. So 9.8 into 2 is 19.6. 2 and 2 will cancel off. So what we have is 19.6. Therefore, the correct answer is option B.